So, welcome to yet another tutorial. So, today we are going to explore the stack data structure, and then we are going to see different implementations of the same. So, we are going to see how a beginner would implement the data structure, how an intermediate engineer would implement the data structure, and how an experienced engineer would implement the same data structure. So, yeah. So, we're going to start with the intermediate, with the beginner code. So a stack data structure is a data structure where we give last in, first out. I think that is the definition. So P4. So in Golang, they would use a structure and then with a list of elements, and then they implement the common APIs for this data structure, like push, pop, the size of, and check if it's empty. So one thing about a beginner's implementation is that the data structure will have like one data type. So like for our case, I've decided to implement it with a list of integers. So we can only keep integers in this stack. This is an improvement that an intermediate level engineer would would an intermediate level engineer would implement differently. So let's see if this works. We can go to SD one, and then we run main.go. So let's see if it works as expected. Yeah, so we create a new stack, and then we push the element one, and then we push the element two. And then when we pop, uh, the last in will be popped first. So we will output two, and then and a nil. Remember, our implementation returned an integer and an error. So, and then the size of, after popping, the size we will be one. And then if we check if it's empty, that is going to be false. So, and then when we pop again, we will remove the last element that was in the stack. And then when we try and pop, we will get an error stating that the stack is empty. So this is a beginner implementation. So how would an intermediate engineer do this? So an intermediate engineer, they would use a generic data type inside the stack. So in Golang, we use an interface. So this can carry all data types. So if we push an integer, we push a string, they will all be kept in this list. So that is one thing that can be noted in an intermediate engineer. It will be the same. So let's see how it works. We create a new stack. We push one. We push the string hello. We pop. When we pop, we will remove the hello. When we check the size of, it will be one. When we check if it's empty, it will be false. And then if we pop and then check if when and try to pop again, it will be it will throw an error. So let's see that in action. Go run main.go. Yeah, as so. How would an experienced person implement a stack? They will introduce, they will make sure their stack is thread safe. So can be concurrently read and can be concurrently written to. So in Golang, we use the sync mutex. So when we are writing, we lock the stack, write, and then release it, release the lock. Uh, yeah. when we are appending, we lock, append, and then release the lock. When we are popping, we also lock and then check, do all that, and then we we release the lock. Even when we are checking size of, because sometimes you would want to check a size of a stack that is being populated. I don't know if I use case for that. So you lock, check the size, and then yeah. So and also an experienced SDE would write tests for the package to check if it works per spec. So and the one that I will focus on in tests for the concurrency. So how would you test for concurrency in this case? We will spin 1,000 Go routines that will be adding and popping at the same time. And we don't expect to have any data races with this. And yeah, that's it. So see you in the next.